Today we're working with Chapter 10, Section 7, dealing with special segments inside of circles. Now, you should probably have already done this problem. That chord right there and this chord right here, there's a special relationship that these chords have, okay? And they're not equal, all right? But wherever these chords intersect, where they intersect right here, it breaks it into pieces of a chord. Right? Something we learned yesterday was that this segment refers to, let's call it A. And this segment right there, that's B. We know the product of A times B is going to equal this piece right here, we'll call it C, and this piece right here, we'll call it D. Now this will always be the case inside of a circle if you have two chords that intersect each other, all right? So A times B is 21 times 7. C times D is X times 20. So you get 20x equals the product of 21 times 7. And to solve for x, all you have to do is divide both sides by 20. And that will be your answer. On your calculator, all you have to do is do 21 times 7 divided by 20. Your answer will be 7.35 units. Sure. All right. Now, these are easy. All right. As far as numbers 1, number 2, and 3, all you have to do is do 5 times x equals 11 times 11. 8 times x equals 4 times 9. We did those yesterday. Okay. When we get to problems that are a little bit more difficult, we're going to go ahead and do problem number 5. All right? And we'll do problem number 7. Now, these intersect not on the inside of the circle, but these secant segments, secant to go through the circle, all right? These are on the outside, okay? So they intersect right here. Now, this process is a little bit different. So we're going to get out the colors, and hopefully you guys will, once again, understand the process. This piece right here is a part of that whole length. All right? So I'm just going to, instead of using a whole bunch of letters, I'm just going to call it a part times the whole thing. Now, these tick marks represent that both of those are 8 units long. Okay? The part is just 8 units long. The whole thing is going to be 8 plus 8, which gives us a total of 16. So we have the part, this piece, times the whole thing is going to equal this part right here times the whole distance, which is right here. So I'm just setting it up, and this would be something you probably want to have in your journal, because it might be a hard rule to memorize unless you teach it for years after year after year. All right, so what's the part equal to? What's our distance? Just a 6. What's the whole length? What do we have to add together? We got to add the 2x and so that would be called 2x plus 6. So we have the part times the whole equals the part times the whole. All right? I'm sure somebody in this room has multiplied 8 times 16 together. Yeah, 128. Equals. Now we need to distribute the 6 to both numbers. And we get 12x plus 36. And now you have to know a little bit of algebra. Just solving for x. Take away 36 on both sides. 12 times x equals 92. Then divide both sides by 12. 7 2/3. So x in the calculator, it'd be 7.6 repeating in the calculator, and everybody knows that's 7 2/3. So x is equal to 7 2/3. Just remember, it's the what? Part times the whole equals the part times the whole. That's how you always have to set it up. All right. I'm going to go ahead down here to number 7. Going to separate it into parts and wholes. Parts and wholes. Try to make it as least complicated as possible. In the math textbook, you see a whole bunch of letters. All right? So right now, if I said, what's the part? What would you say? 5. Be careful now. What's the whole? Yeah, good job. It's the 13 plus the 5. Good job. All right? Put a big old equal sign here. All right. What's the part? And what's the whole? X plus 9. Very good. This one gets a little bit trickier because we're dealing with an x being multiplied to an x, and then an x being multiplied to a 9. Now 5 times 18, that's easy. That's just 90. We get 90 equals x times x, which is x squared, and we got a 9x. Now we have a quadratic. Now a quadratic equation, if you remember from Algebra 1, all right? This is the standard equation for a quadratic equation. We have ax squared plus bx plus c equals 0. So what we always want to do is we want to set it equal to 0. So how do we set this equal to 0? Just take away 90. Take away 90. And here's your quadratic equation. X squared plus 9x minus 90 equals 0. Now, there's many ways to solve a quadratic equation. The first thing I always do is ask myself, can I factor this? Can I factor it? How do you mean factor it? I haven't factored it in a while. Well, you're looking for two numbers that multiply together that equal -9. But those same two numbers, when added together, equal a positive 9. Let's think about that. So let's think of the factors of 90. Well, you guys know that it's 90 times 1, right? Well, those don't add up to a 9. Those add up to like a 91. All right, then we have, you probably are like, all right, well, there's 45 times 2. All right? What else? 30 times 3, right? That's 90. Well, there's 15 times 6. That's 90. And then there's 10 times 9, right? Typically, people just think of what? 10 times 9, that's it. It's just 10 times 9. But these are all the what? These are all the factors, okay? Now, they have to multiply together to equal a -90, but somehow add up to get together to equal a positive 9. And here's your group you have to look at. If you're confused, that means you didn't learn in Algebra 1. Okay. So here's what you have to do. Are any of these numbers somehow, can they add up together to equal a positive 9? What's 15? Minus a 6. No. So if I say 15 times a -6 and 15 plus a -6, these are the two culprits, all right? Whenever you're trying to factor stuff, okay? By the way, here's a quick little review. Now here's an easy one, right? If I said, what's x squared plus 5x plus 6, that's easy. What two numbers add up together to equal 5 but multiply together to equal 6? 2 and 3. Remember doing those? Yeah, you got 2 plus 3 is 5, and 2 times 3 is 6. All right, here, one more. I bet you guys will get this. Two numbers that add up to 10 but multiply together to equal 5. There you go. We had a little bit trickier one. Ours was, hey, two numbers had to add up to a 9, but somehow multiply together to equal negative 90. So it was a little bit harder. That's why I'm doing it with you. All right? So what are our factors? Our factors are x plus 15 and x minus 6 equals 0. Now, the solutions are the numbers that you have to plug in to make them equal to 0. So what number plus 15 equals 0? Negative 15. That's one of your solutions. What number minus 6 equals 0? Positive 6. All right? So these right here, all right, these are your solutions. You have two solutions. One solution is a negative 15, and one solution is a 6. Now I'm going to tell you, one of these answers does not work, and it doesn't make sense for dealing with distances. Which answer do you think would be probably not the one you would want to use to plug in right there? Negative 15. That's called an extraneous solution. So we're going to cross it off. We're going to call it extraneous. Extraneous solutions are solutions you come up with that actually work in a quadratic, but they don't apply to real life. This number is the number that you need to go right here. That's the number that works. All right? Now, if you want to prove it, here's how you prove it. 6 is the part. What's the whole? 6 plus 9, which is 15. And what's 6 times 15 equal to? We figured that that's equal to what? 90. All right? What else is equal to 90? 5 times 18. I guess I should have added another one here. Whoops. All right? So all these factors are answers that could work when you're dealing with the quadratic equation. All right? So your answer for this one is just the final answer is 6, but you had to start the process to get to the quadratic equation. Now, not all, there's only one of those I threw in there. I just wanted to test your algebra skills. All right? Last one we're going to do, actually, no, we'll do two more. We'll do 8 and 9. There we go. I'll help you start out 6. We'll help you start out 6. All right? Now, right here, we have a part, and we have the whole enchilada right there. Okay. All right. So the part of the enchilada is 20. The whole enchilada is 45. Now this is kind of cool. You're like, okay, what's the part? What's the whole? Guess what? This is the part, and this is the whole. So this segment right here, that's tangent to it, okay? You use it not once, you use it twice. So you set this equal to x times x, which makes it really, 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 really easy. What is x times x? X squared. So we know this is equal to x squared, and 20 times 45, what's 20 times 45? 900. And then whenever you see something that's squared, what do you have to do for the final step? Just take the square root. And sweet, we get x equals 30. And that's your answer. Is 30 times 30 equal to 20 times 45? Yes. Okay. So these are actually the easiest, I think. All right? This is the part and the whole. Just multiply together. Kind of like if you're an only child, you're the oldest and the youngest. All right, number 6. All right, let's get it set up, and then we'll set up number 9. Here, I'll start with red and blue. Here's the red. Here's the blue. All right, what's the part? Part is x. What's the whole thing? X plus 5. Got the part. Got the whole. All right. What's the part, everybody?
6.
Yes. No. Yes. 21. Very good. All right. Why is it 21? Because we have to add the 6 and the 15 together. So we distribute. We get x squared plus 5x equals, what's 6 times 21? 126?
Oh, I did it wrong.
26. So what is this quadratic? What do we have to set it equal to? All quadratics set equal to 0. We have x squared plus 5x minus 126 equals 0. All right? Now, 126 is a kind of a nasty number. Okay? Now here's kind of a cool rule. What's 1 plus 2 plus 6? 9. Now here's kind of a cool rule. If you can take any number in the universe and add up all the numbers in it, and if it equals a multiple of 3, you know it's always divisible by 3. Now, what are you talking about? Well, 1 plus 2 plus 6 is equal to 9. Is 9 a multiple of 3? Yes. So I know 126 is a multiple of 3. 126 divided by 3, it will have a factor. 42. Now, here's what I'm going to do. I'm going to help you guys out. Okay? Can you guys tell me what 9 times 14 is equal to? I'm going to help you out. 9 times 14. What's that equal to? What's it equal to? You're right. It's equal to 126. All right? Now, what is negative 9 times 14 equal to? Negative 126. Now, what is negative 9 plus 14 equal to? 5. Now, what you're trying to search for is you're trying to search for two numbers that multiply together to equal negative 126, but those same two numbers add up to a 5. But I'm not going to tell you what those numbers are. Okay? When you're trying to factor this, you're looking for two numbers in the universe that multiply together to equal negative 126, and those same two numbers add together to equal a 5. So I'm going to put a minus 9 here. I'm going to put a plus 14. Now, these, by the way, you guys remember the old FOIL method? All right? If you FOIL this out, this times this would equal all of this. If you don't know how to do the FOIL method, Google it on Khan Academy and look at it. All right? Pretty easy. Now, these are the factors. Now, what are my solutions? What number minus 9 equals 0? 9. What number plus 14 equals 0? Negative 14. Which answer would be the stupid answer that's not going to make sense when you're dealing with distances? Negative 14. We're going to cross you off and call you extraneous. So what's my final answer that will work? 9. Yes, that's the number that you're searching for that we just found. Okay. All right. So just remember, when you're doing these problems, they're either going to intersect on the outside or they're going to intersect where? On the inside. These are the easiest problems. This is the one that you hope that you get on a quiz. All right. This is the problem that you hope you don't get on a quiz. All right. Trust me, if you get a quiz, I'll probably have a problem like this, where the x is on the inside, not on the outside. If x is on the outside, what are you going to always get? You're always going to get a quadratic. You're going to get an x squared. So if you see an x on the outside, like here and here, that's when you need to